Hello and welcome to the second video about analysing substances, and for this one we are looking at gas chromatography. We've already looked at paper chromatography, but this is a slightly different and more sensitive method for analysing substances and finding out what chemicals are present in a sample that you might be looking at. Now the first thing to remember or to understand is how the whole thing works. I've got a rough diagram of what's going on here, and I've just broken it down into stages. So the first stage would be that you have a sample, and the first thing you have to do is to vaporize it. In other words, to evaporate it, make it into a vapor, and pass it through a column. Now by a column, on the diagram it's this little part here. It doesn't actually look like a column, it looks more like a tube, but that's what we call the column. So we vaporize it and pass it through a column. The way it gets through the column is that it has to be carried by a gas, and this substance, this canister here, provides that gas. It's usually something like nitrogen, which won't react with anything. But we have the sample vaporized, the gas then carries it through this column, and the key thing about separation happens in that column. So if we look at a part of this and just magnify to see what's going on inside there, we have a solid material that's packed inside that column, and what happens is your material passes through, the chemicals are carried through the column, and because the way the column is designed, it causes different materials or different chemicals to pass through at different speeds. And that means if they're passing at different speeds, they then separate out. So the next part of it is then that a detector from the other side, so the materials pass through, they all come through at different times. A detector detects the different chemicals and shows them as peaks on a chart. So we have an output here, and every time something comes out, a chemical comes out, we see a peak on the chart, and we can use that to identify what those different chemicals are. So if we just have a look down here, here's my readout from this little experiment here, and here's my known substances, so I can compare the readout that I got from my sample to known substances, and you can see what you have. So for this one here, if I look at this peak on my sample, compare it to my known, that looks like it's substance A. I've not got any substance B. This one looks like it's C. I've got some D in there as well. If I just straighten that out, I've got some D in there as well, and some G and some of this H. Okay, so what I've done is I've compared my readout to some known substances and the peaks they produce, and that can tell me what's in there. The amount of time that the chemicals spend inside this column is called the retention time. And so this really is a comparison of the retention times. The substances that come out first are nearer the beginning here, and the ones that come out towards the end are nearer the end. The longer the retention time, the more time a chemical will spend inside the column, and in that way they get separated out. The other thing to remember then is that we can compare our substances like this, but we can also add what we call a mass spectrometer, and a mass spectrometer is something that's added to the end of this, which is an extra analysis tool. And that means if you add this on, what you can do is you can actually identify the substances, or the chemicals. So the mass spectrometer will actually identify it for you rather than having to compare to a retention time graph. Now the next thing that I want to just quickly cover is this idea of what the actual mass spectrometer does. This is actually on the higher tier, so if you're not doing the higher tier you may not need to know this, but basically what we have is a chart that's produced something like this, and this is called a mass spectrum, and it's produced by our mass spectrometer. And what we can tell from this is we can actually work out something called the molecular mass. We can work out the molecular mass of substances coming through the gas chromatography apparatus, and we do this by looking at something called the molecular ion peak. Now you don't really need to know too much detail about this because it does get quite complicated, and I think it spills probably into a little bit of A-level chemistry, but the molecular ion peak is the one that's found on the right of this mass spectrum, and you can read that off and that will tell you the molecular mass. This actually is not a completely accurate label here. It's something called the MZ ratio, but now we're getting a bit too complicated. For you, what you need to know is that the mass spectrometer can identify the molecular mass. You can do that by looking at the molecular ion peak, and there's one more detail that I need you to know. I've written all over that there. One more thing that you need to know is that a mass spectrometer can identify chemicals quickly, accurately, and can detect very small amounts, and this is why it has an advantage over paper chromatography. So we can identify quickly, accurately, and very small amounts. We say, for that last one, we say it's sensitive. So if you've only got a very tiny sample of a chemical, you can still identify it because mass spectrometry is very sensitive. So that's an overview of a second method we can use to analyze substances called gas chromatography linked to mass spectroscopy. That's it for me today for now. Thanks for watching, and I'll see you again soon.